First couple sections here. If chapter 3 is old school stuff of solving system equations by graphing. So we're going to graph and we'll find some solutions and so forth. Anyone remember where the solution of a system of equations is when you graph? What does it look like graphically?
Where the lines cross.
It's where they intersect, the intersection of the two lines. Okay. So the overarching idea today is we're going to graph two lines. We're going to graph two functions and then see where they intersect. And that'll tell us the solution to a system of equalities. Okay. So graphing in standard form, probably the easiest way to graph if your lines are in standard form. You could rewrite them in slope-intercept, or you could just solve by using the intercepts. So when x is, say for example, when x is 0, what's the y value of the first line? When x is 0, we'll find the y-intercept. So negative 2y equals negative 10, or y is 5. For our first line, our y-intercept is 5. 1, 2, 3, 4, 5. The x-intercept is when we leave x and put 0 for y. So what's our x-intercept of our first line? Negative 2. Plug in 0 for y and get 5x equals negative 10. X is negative 2. And then we can draw a straight line through them. You get a nice straight line through them. Okay? This would be line 1. Okay. Line 2, we can repeat the same thing. So line 2, for line number 2, we play the same game. The y-intercept is when there's only y and no x's. What's the y-intercept? Negative 3. The x-intercept is when there's only x and no y's. So the x-intercept should be 6. 1, 2, 3, 4, 5, 6. And I think I'm going to have to draw this, we'll see. I think I'm going to have to draw this with my hand. Whoops.
That's true. I also had that.
Namely, this point where they seem to cross, and that point is what? 1, 2, 3, negative 4, negative 5 is where they seem to cross. Is the solution I'm going to test. And I say I'm going to test that solution because, as you can tell, one of my graphs looks like it's kind of nicely straightly drawn because I have the function on my computer. The other one is pretty bad. It's not even close to being a straight line, but it's a good estimate. So this is merely just a test point if we're doing this by hand. So I'm going to test this by plugging in and checking to make sure that it's a solution in each of those two equations. If it's a solution to both, then we're good. If it's not, then I might want to go back and redraw my lines and make sure that I actually can draw them straight. Okay? So let's test and make sure that my writing was correct. So we have 5 times negative 4 minus 2 times negative 5. Does that equal negative 10? Oops. Well, let's see. Negative 20 minus negative 10. Negative 20 plus 10 is negative 10. Yeah. That is a solution. Is 2 times negative 4 minus 4 times negative 4. Oops. Is that equal to 12?
Yes.
Negative. Is this supposed to be 5? This is supposed to be 5, right?
No, the other one.
Correct numbers in, we might actually get the right answer. So negative 8 minus negative 20, negative 8 plus 20 is exactly 12. Yeah. So our solution to this system of equalities is negative 4 comma negative 5. Yahoo. Did it right.
Will the point always be on the exact?
A system of equations that have a solution. They have at least one. They are inconsistent if they have no solutions. What types of lines have no solution? What types of systems have no solution? Louis, since you raise your hand. They are parallel, yeah. Lines that are parallel never intersect, so they have no solution. Okay? Independent systems are equations that have exactly one solution.
So that means they only intersect at one spot.
Consistent independent equations they have a solution and there's exactly one of them. They're lines that just intersect once. If they are dependent, then they have multiple. And in fact, for linear systems, they have infinitely many. Solutions. Alright, we compare the slopes. Hopefully you compare the slopes. In the first one, we rewrite this equation. The first one we could say is, say, negative 2y equals negative 6x plus 8, or y equals 3x minus 4. Rewriting the second equation, you get y equals 3x minus 4. These have the same slope, so they're parallel. They also have the same y-intercept, so they're stacked on top of each other. These are consistent and dependent. The second equation, rewriting, we get y equals 4x plus 5, y equals 4x minus 2. These are parallel, and they have different y-intercepts. So they are not on top of each other, and they're parallel. They never intersect, so therefore they are inconsistent. The last one, we can rewrite the top equation, you get y equals 2x plus 5, and y equals negative x plus 2. They have different slopes, so right off the bat, that means if they have different slopes, they have to intersect exactly once. These are consistent, independent. Right? Okay. So we'll graph to find the solution area to a system of inequalities. We'll graph both, shade both, and the solution area is where they overlap. Okay? So in this case, we have, say, the first line, we have y-intercept of 2, slope of 3. It's a solid line. It's a solid line because it's or equal to, and it's less than, we could pick a test point, say 0, 0, and say, is 0 less than 2? Yeah. So we'd shade below this line. Okay. The second one is a y-intercept of 4, 1, 2, 3, 4. A slope of negative 1, so down 1 over 1. It's a dotted line, it's not or equal to. We could plug in a test point. Is 0, since 0, 0 is not on, is 0 bigger than 4? No, 0 is not bigger than 4. So we'll shade away from the test point, which would be here.
So the solution is like.
So then the solution area would be everything in this space. Okay. The solution area is where they both go. Let's do a couple that kind of look neat, look pretty neat. How about y is less than 2? What's special about y is less than 2? What kind of line is that? Horizontal through 2. Is it dotted or solid? It's a dotted horizontal line through 2. And less than 2, pick a test point. Is 0 less than 2?
Yeah.
Yeah, so we'll shade down here. Ooh, absolute value. Yay, we just did this. Absolute value of x is minus 1. What is that graph going to look like? Alex?
Go the right one and
Go the right one.
like draw V as if it had a slope of 1.
And draw v's as if the slope were a nice positive 1. And it's solid lines because it's or equal to. Then you could pick, say, test point, plug in, say, 0, 0. And is 0 bigger than the absolute value of negative 1?
No.
Is 0 bigger than 1?
No.
No, 0 is not bigger than 1. So we'll shade, how about like this area? So then where is the solution to this system of inequalities?
Middle of the triangle.
This little triangle is the only place that all three overlap. That triangle is our solution area. It's the only place that they all intersect.
Just color the area.
The last one's good news here. Okay, x is greater than 10. Vertical line through 10.
It's solid.
It's solid. I'll wait, since there's 4 of them, I'll wait and do all the shadings after. Okay, so vertical line through 10. Vertical line through 70.
Oh my gosh, why do I keep missing this?
Y is less than or equal to 8/7 of x. So this is what's the y-intercept of the first line?
0.
0, and it goes up 8 for every 7. 7, 8, and it goes up 8 for every 7. 1, 2, 3.
Wait, I did that because it goes up by 10s. Is that supposed to be 80 over 70?
Okay, what's 80 over 70 reduced to?
Oh.
Ouch.
8 over 7? Yeah, so you can make it fit the scale, right? You could go up 8 and over 7, or we can expand it to fit the scale a little bit. Since the scale's kind of by 10s, we can multiply top and bottom by 10s to make it fit our scale a little bit better. Then we'll go up 8 over 7, and it's a solid line.
Oh, but I still got the same answer.
Yeah, you get the same thing.
Oh my god.
Yep.
I just erased
And then y is greater than or equal to 2/7 of x, so we do the same trick. Let's multiply top and bottom by 10 to make it fit our scale. And we can go up to, starts at 0, and go up to, and over 7. The solution area to the left, to the right, below, and above has got to be anything that's in that area would be our solution area.